Okay, this is just a quick tech demo of my Algorithmic Quartet Generator. All of the logic has been coded and everything works except for the final step, which is composing the gestural database that it will draw from in order to actually produce algorithmic music. Really quickly as background, this came out of the idea of NFTs and looking at non-fungible tokens. And in fact, it's a very easy code that I found there. Most NFTs are created by having 10 different background layers, 10 primary layers, 10 secondary layers, 10 tertiary layers, which gives you a total of 10 to the fourth or 10,000 different possibilities. In fact, this is extremely easy to code out. Here's the Python script, and including comments and blank lines, it's less than 30 lines of code. Just using nested for statements to concatenate various strings together. Very, very simple. However, in Max, it's used in an interesting way. What I've done is I've created a collection file of the type index number A, B, C, and D. And this will give you up to 0 to 9,999 different indexes, each of which could be a digit from 0 to 9. Within that is what the Quartet generator is using. So let's take a look at how it accomplishes that. When you hit the button to send a bang, that actually triggers an Uzi that sends out 4 bangs. Each of those goes to the collection index, which is currently set to have only 3 to the fourth or 81 possible values. And the reason for that is that I just programmed 3 basic demo gestures into here to test it before I get down to the hard work of actually writing music. All of those are packed and routed by the voice number. The counter up here associates a voice number with it, so of course this can be scaled up pretty easily. The routing goes to the various parts. Inside of that, we separate it, and we've got a collection. Whereas it's currently being created with random values, in the final version I'm going to replace that with an earn, so that it will only pick random values, but it won't use any multiple times. Here, that collection is joined and routed with the voice number, with that going into a ordering. So you've got 6 possible ways to order that. And inside of that, you can see I've got algorithm A, B, and C, which will be replaced with collections just in different places. The first voice is stripped off, and that becomes the pitch offset. Then all of these are created in reverse order in order to make sure that everything is joined together and triggered simultaneously. All of the pitches go through a scale pitch subpatch where it is taking a pitch offset and the current pitch and then packing those together, summing them, and then making sure that they are within the logical boundaries of the low and high notes of the instrument's range. If they are, fine. If not, then it adds 12 if it's below the range of the instrument to bring it up by an octave. If it's above the instrument's range, it drops it down by 12 semitones to bring it back within an octave. All of that is output. And then the final pitch of the musical gesture is stored and sent to the current pitch value. So 3 lists of different pitches are concatenated along with 3 lists of associated durations. All of that is wrapped, and finally it is output into the make measure abstraction, where everything is collected and everything is packed up with a time signature and BPM value. And then it also looks at the final measure number of the previous gesture and says, go to that last measure that was previously generated and make sure that that is always displayed in the score object so you can always see where you're currently at. And really, that is just working the same for all the parts. I've got this set up as a string quartet currently with violin, viola, cello, and second violins up here. All of those can then be dumped and joined into one large score, which can then be played and can also be exported either as a MIDI file or as a music XML file. So in order to use it, all you do is you decide first, do you want to use a random seed or do you want to just use the clock time? I'm going to use a random seed, and we'll program it with 747 because that sounds like an appealing number. Then you make sure that before you start, you have initialized the high limit and the low limit for each instrument so that it won't play anything out of bounds. You can also set the initial pitch. I think I'm going to start everything for the violins on D3. The viola, we're going to go to, how about A2? And for the cello, how about A1? There we go. Then I just hit bang to create a measure. And you can see the test gestures that I've created are very, very not particularly great musically, but they are programmed to be easy to see. So I've got a ascending run of septuplet eighth notes. I have a gesture of septuplet 16th notes. I've got descending 16th notes. I have a eighth note, quarter note, eighth note tie, and there are a couple of other ones. There's a quintuplet gesture, but just very, very easy stuff that you can see and hear, and it's not the best, but it will be easy to pick out if it's working or not, and that really is kind of the case here in the beta version before I actually compose all the final gestures. So I'm just going to create a couple more measures. And then I'm going to clear and initialize my final score, dump it, and make sure that all of the measures have lined up, which they have not. I need to clear it and dump it again. There we go. And now everything ends exactly as it's supposed to in bar 16, and I can go through and compare any of the parts in their initial scores that are generated one at a time to the final version. If I want, I can, of course, export that as MIDI or music XML, and I can also play it using the built-in easy MIDI player in the Bach library. I can play that by selecting to play from MIDI, and it will. And it just uses a basic MIDI piano sound, but that's not really interesting. So instead, I've got everything going through a VST, in this case through East West's Hollywood Strings. So I have a virtual string orchestra set up and ready to go. I just click anywhere in the score and hit Spacebar, and it will play. Okay, that actually turned out a little bit better than I was anticipating. What is really fun about this, though, is that I can also play around with the limits after I generate each measure before I generate the next one. I have a limit range subpatch set up for all of these, so as I increase the low limit for violin 1, if the pitch initialization is below that, it will automatically bump up to the low limit, and conversely, if it's above the high limit, it will bump down to equal the high limit. So let's take that up considerably higher. And we'll do the same with the second violin and the viola. And of course, these can never be set so that they are anything other than an octave apart for the low limit or the high limit. That's just to prevent any type of dropout. I'll take the cello down, actually. And then let's generate some more measures. And you can see how the resulting notes are changed in terms of the range while the gestures stay the same. I'm going to redump everything to the final score a second time. And now everything lines up correctly, and we've got 20 full bars ready to play. So this is, as I said, the initial beta version of this algorithmic quartet generator. The next step is going to be really kind of the hard part, and so I'm waiting to go on winter break from the university before I can actually do that, which is to compose all of the different musical gestures. And there will be at least 30 of those, although I could always do a fourth level where the initial pitch also ties to a separate gesture. So it's going to be a lot of composing and then quantifying those in terms of semitone, offsets, and the durations. But yeah, it's very, very simple, and using the Bach package that is available in the package manager, this has just been very easy to put together. I've spent just over 8 days creating everything, and it works. And once I've got a finished version ready, I will have that on my website.